4 is about. It is show that the following function z plus 150x minus 2x cubed plus 3y cubed minus 6xy squared equal to 0 give the saddle point at point -3 and -4. Hence, find other stationary point and determine its nature. So, my group members will explain further about the solution for this question.
Hi, my name is Amir Rahman. I'm going to show you the method how to answer question 4. We are given this question to find its saddle point. We already know that z equal to f x y. Then we brought z to left hand side and others to right hand side, which is equal to 2x cubed minus 3y cubed plus 6xy squared minus 150x. That is equal to fxy equal to this equation. Then we broke it down to x component and y component. First of all, of x component, fx equal to only x component that are differentiated, that is 2x cubed and 6xy squared and 150x, that is 6x squared plus 6y squared minus 150. Then we find the fy, that is equal to that we only differentiate of y component, that is y negative 3y cubed plus 6xy squared. If we get negative 9y squared plus 12xy.
Hi madam, my name is Asif and yes, I will do the next part. Okay, now from previous part, we obtain that fx is equal to 6x squared plus 6y squared minus 150 and fy is equal to negative 9y squared plus 12xy. Okay, now we must equate both of these quotients 0 to 0. I label this is first question and this one as the second question. Okay, now since we see that fx is quite hard since it is involving two quadratic equations, so I will do the fy first. So we will obtain here 12xy is equal to 9y squared. Then x is equal to 9y squared over 12y. So this, and by simplifying this, we will obtain that x is equal to 3 over 4y. And then we will substitute this in the first equation. Okay, now we will do the next part. Substitute this in this. So we will obtain that 3 over 4y squared plus 6y squared minus 150 0. Okay, next one. 9 over 16y squared plus 6y squared minus 150 is equal to 0. Okay, times it is 54 over 16y squared plus 6y squared minus 150 is equal to 0. We will obtain next 54y squared plus 96y squared minus 2400 is equal to 0. By adding this, both of these are 150y squared is equal to 2400. Then we solve this, we will obtain that y squared is equal to 16. Y is equal to plus minus 4. Okay, until that we will see it in the next part. Okay, next we substitute the value of y into this equation to find the value of x. So we obtain that x is equal to 3 over 4 negative 4. We will obtain that x is value of negative 3. Next one is x equal to 3 over 4 times 4. We obtain that the value of x is 3. So here we can get two value of points. So the first point is negative 3 and negative 4. Next point is 3 and 4. So done here.
My name is Muhammad Alimi Badrahin. So now we will go to the next part. So after we obtain the first derivative, in my part I will show you how to find the second derivative. So first of all, we need to use a differentiate method. First, we need to find the f(x)(x). f(x)(x) can be obtained from the first derivative from 6x squared. So we will get 12x. After that, we need to find the fyy. fyy also need to find from the first derivative from this. So we will gain we get fyy as a second derivative like this. Lastly, we will find the fxy. So fxy need to be differentiated in an opposite direction like this. The answer for the fxy from here is 12x, because we differentiate x from the 12xy. That's all.
Hi madam, my name is Mother Vivi. So now, as the previous part, Alimi has explained about how to derive the second derivative. So now I'm here to prove the negative 3, negative 4 is the saddle point. Okay, now the point is negative 3, negative 4. Now I will substitute this into three equations. Okay, first f(x)(x) equals to 12, x negative 3. So I will substitute. I will get negative 36. Second, fyy negative 18 point plus 12x. Now I will substitute fyy negative 18, y is negative 4 plus 12, x is negative 3. Okay, so now I will get the answer will be 36. Okay, third is fxy equals to 12y. So fxy equals to 12y. 12, y is negative 4. So the answer negative 48. Okay, now to determine the nature of point, there are four conditions. First, when d more than 0 and fxs more than 0, if the function has relative minimum point at given point. Second condition is when d more than 0 and fxs less than 0, the function has relative maximum point at given point. Third is when d less than 0 and the function as the saddle point at the given point. And fourth condition is when d equal to 0 and then the function, and then no conclusion can be drawn. Okay, now I will find the value for D, value of D. So the formula for D is D equals to fxx fyy minus fxy squared. So here I have three values. I will substitute these values into this equation. Fxx negative 36, fyy equals to 36, minus fxy equals to negative 48 square. So the answer is negative 3600. Okay, now since D less than 0, the function as the saddle point at given point, which is negative 3, negative 4, and it is proven.
Hello madam, my name is Maheshni. I am here to explain the sub-question that asked in question 4. Question 4 requires us to find another stationary point and determine its nature. In step 2, Haziq has explained and he calculated 2 points, which are 3, 4 and another one is negative 3 and negative 4. So another stationary point is 3 and 4. To determine the nature of this point, we have to calculate the D value. To calculate the D value, we need the value for fxx, fyy and fxy. So to determine the value, now I'm gonna find the value for these functions. First, to find the value of fxx, I'm gonna substitute x with 3 and I get 36. For fyy, I substitute y with 4 plus x with 3, I will get negative 36. For fxy, I substitute the y with 4 and I will get 48. Now we're gonna find the value for D. The formula for D value is fxx times with fyy minus fxy squared. So we substitute the value. Fxx is 36, fyy is negative 36 and fxy squared is 48. So the value we get is negative 3600. Since D value that we get is negative, so D is less than 0 and the function has a saddle point at the point 3 and 4. Thank you.